well, first, I'm picking up where I left off from last time. I corrected the issue, and I certainly hope that you can see the entire full screen. I have no way of knowing that. So if you get stuck with a small slide, I do apologize. Okay, so we're going to distribute the x, which gives me x cubed minus 11x squared minus 3x. Then we'll distribute the 9, which gives me 9x squared minus 99x minus 27. Then when I combine like terms, I get my x cubed is all alone, so I get it. And then I have negative 11x squareds plus 9x squareds, which are negative 2x squareds. Then negative 3x and negative 99x is negative 102x. And negative 27 at the end. So that's a good instance where standard polynomial order helps to add structure to how we're going about our work. So that was all the work we had covered going into, or all the recent work we had covered going into the last class. Then we began to talk about the idea of reverse engineering, and we compared it to the aliens at Roswell. So the first type of reverse engineering we talked about was factoring with the greatest common factor. Why don't you try the first three? We'll go over the answers to those, and then we'll do the next three. Okay, so for the first one, it says 15n minus 20. So what do they share in common? They share 5. So that gives you 5 times 3n minus 4. The next one, what do they share in common? They share a 4, which gives me 4 times, oh, that should be 5g plus 6, not g plus 6. That should be 5g plus 6. Okay, as a matter of fact, let me go correct it right now so that I don't have an issue or a problem. Okay, 5g plus 6. Okay, and let's go play from cards. So we did the first one, now this one. We factor out the 4, we get 4 times 5g plus 6. And on the next one, we can see that they also share a 4 in common. Yes, they share a 2 in common, but the greatest common factor is 4. So I factor that out, and I'm left with 3x minus 7. Checking back, 4 times 3x is 12x. 4 times negative 7 is negative 28. Let's see you guys try the next one, which is 4, 5, and 6, that next row. Okay, so for number 4, they all share a 5 in common, and notice that they don't all have an a. Only the first two terms have an a, so I can only factor out the 5. Distributing back, 5 times a squared is 5a squared, 5 times negative 3a is negative 15a, and 5 times 2 is 10. Remember, you're factoring out, which is anti-distribute, the greatest common factor. For number 5, the greatest common factor they share is a 3 and an a. So I factor out the 3 and the a. 9 divided by 3 leaves 3, and a squared means AA. I pull one of them out, there's one left. Let's distribute back and check. 3 times 3 is 9, a times a is a squared, and 3a times 1 is 3a. So that checks, okay? Number 6, they share a 5 and an a, so I factor that out, and that leaves me with an a minus 14. Checking back, 5a times a is 5a squared, 5a times negative 14 is negative 70a. So that's the first type of factoring that you have to do, which is factoring with the greatest common factor. Next up, double distribute. And this helps because it's much easier to understand factoring if you can double distribute well. So let's try numbers 1, 2, and 3. Do all of those. Okay. Okay, so let's check out the answers. So for the first one, I'm going to distribute the x, so that's x squared minus 5x. And then I'm going to distribute the 3, so that's 3x minus 15. The middle terms are combinable. Negative 5x and 3x make negative 2x. Okay, next up. The next thing that we're going to deal with is double distributing 2x plus 7 across the x plus 2. So distributing the 2x would be 2x squared plus 4x. And then distributing the 7 would give me 7x plus 14. Combinable in the middle, that's 2x squared plus 11x plus 14. Last but not least, number 3. If I go to distribute the 4x, I get 4x squared minus 20x. And if I distribute the negative 3, I get negative 3x plus 15, combinable in the middle. That's 4x squared minus 23x plus 15. I do want to call something to your attention here. Notice how if I look at this as an AM situation, okay, when the lead coefficient of the trinomial at the end is 1, yes, 3 times negative 5 is negative 15, and 3 plus negative 5 is negative 2. So AM is definitely workable whenever the lead coefficient of a trinomial is 1. However, notice this next one, number 2, and then also number 3. Number 2, 7 times 2 is 14, but 7 plus 2 is not 11. And in number 3, negative 3 times negative 5 is 15, but negative 3 plus negative 5 is not negative 23. So what I taught you last week about AM only applies when the lead coefficient is 1. It does not apply when the lead coefficient, that's the first coefficient you see in front of the highest x squared term. When that's not 1, you can throw out the idea of the AM technique. You can also throw out the factoring of the greatest common factor. You have to take alternative stretches when the factoring is not 1. Okay? Here's those observations again about the AM method. Only works when the lead coefficient is 1, and the graphing calculator technique only works when the lead coefficient is 1. Okay? Last bit of review. Let's factor these. Let's do the first row, then we'll do the second row. You'll notice every one of these is a lead coefficient of 1, so you should be factoring the way you factored the other day. So let's do numbers 1 through 4. Okay, so let's take a look at this here. For the first one, I need what two binomials will multiply out to this. So I'm looking for two numbers that multiply out to 20, add up to negative 9. That would be negative 5 and negative 4. So that means my binomials are x minus 5 and x minus 4. Now, had you done it on the graphing calculator, the first thing you put in for y1 is 20 divided by x. I do like to put it in parentheses. You must put it in parentheses later if it's negative. So why not get in the habit of just putting it in parentheses anyway? Y2 is going to be in parentheses the same exact thing that was in y1 and then plus x. Okay? Then you would look in the last column for a negative 9 and see what the two previous columns said. In this case, it would have been negative 5 and negative 4. And then you have your binomials. Okay, for number 9, I'm looking for two numbers that multiply out to 40, add up to 13. They are 8 and 5. So my factors are x plus 8 and x plus 5. But what if you're not so good with your multiplication facts and your number facts and your addition facts? It's not a problem. You go to your graphing calculator. In y1, it's always the last number divided by x. So in this case, 40 divided by x. And in y2, you get into, you want to get the same exact thing as in y1 and then do plus x. Okay, same exact thing as in y1 and then do plus x. In the last column, you're going to look for a 13, and then the factors of the two previous columns, which you're going to say 8 and 5 or 5 and 8. The order is not important. That's an example of the commutative property there. Okay, number 10, we're going to multiply out to equal negative 18, add up to positive 7. That gives me 9 and negative 2, because 9 times negative 2 is negative 18. 9 plus negative 2 is 7. So the factors are x plus 9 and x minus 2. If you prefer the calculator approach, for y1, you're going to put negative 18 divided by x. It's always whatever the last number is divided by x. That's how you get y1. y2 will be exactly what was in y1. Make sure it's in parentheses, plus x. And that will, then you look in the last column for a 7, and then you look back at the two previous columns, in this case a 9 and a negative 2, and that will tell you whatchamacallit, that will tell you what the factors had to be, x plus 9 and x minus 2. All right, for the next one, number 11, I'm going to multiply out to negative 30. I'm going to add to negative 7. So what two numbers multiply out to negative 30 and add up to negative 7? Negative 10 and 3. So my factors are x minus 10 and x plus 3. Now, if I want to use a calculator to figure this out, under y1, I'm going to put whatever the last number is divided by x, which in this case is negative 30 divided by x. That should not say negative 10. It should say negative 30. That's left over from the last time I did this. y2 will say the same thing, negative 30 divided by x plus x. And if you look back, you'll see negative 10 and 3. So under the y-calc one here, this is just I just forgot to change this from the previous problem. It should be negative 30 for both of those. Okay, let's have you try numbers 12 through 14 now. Go ahead. Okay, so in this case, we're going to need to multiply out to negative 40, add up to 3. The two numbers that do that are 8 and negative 5, because 8 times negative 5 is negative 40, and 8 plus negative 5 is positive 3. That gives me the factors of x plus 8 and x minus 5. Now, if you're uncomfortable with that, use the graphing calculator. Under y1, you're going to put the last number divided by x, which is negative 40 divided by x. Under y2, you take whatever's in y1, make sure it's in parentheses, and do plus x. On the last column, you're going to look for the middle term, which is positive 3. Look at the two previous columns, which are when you find the positive 3, and you'll see 8 and negative 5. Number 13, you're going to multiply out to negative 51, add to negative 14. Now, this shows to me why everybody should know the calculator trick, because not many students know the factors of 51 off the top of their head. The truth is, the two numbers that multiply out to negative 51 and add up to negative 14 are negative 17 and 3. That means the factors would be, I don't know why I wrote m equals negative. I was a step ahead there. You should multiply out to negative 51 and add up to negative 14. The factors are negative 17 and 3. So my binomials are x minus 17 and x plus 3. But most students are not going to know that particular combination of number facts. So under y1, you're going to put the last number divided by x, which is negative 51 divided by x. And under y2, you're going to take the same exact thing as in y1 and add x. Okay, so, and then of course you look for negative 14 in the last column, and you say, what does it say in the two columns before that? In either order, it will say negative 17 and 3. Now, number 14 is a tricky one, even though the numbers are low. This time, it's what a lot of people would have expected it to have been last time. Two numbers that multiply out to negative 6 and add up to negative 5. Well, it should say negative 6 for multiply. You know, I got to tell you, I actually changed this from the old one. And the old one was positive 6, so I forgot to change what the m equals there. Sorry about that. The two numbers that multiply out to negative 6 and add up to negative 5 would be negative 6 and positive 1. So the correct answers are, the correct binomials are x minus 6 and x plus 1. If you do it with your calculator, it would be the last number, negative 6 divided by x, and then whatever it says for y1 in parentheses plus x. Last column, you're going to look for negative 5, then look back in the two previous columns, and you will see negative 6 and 1. Okay, so that's factoring trinomials using the AM system. And now we come to the problem. This will be where we teach the new stuff for today.